We're talking about this chapter here, which is this one. There it comes. All right. So, we're talking about debugging tools for C from the same online textbook. All right, so we'll talk about GDB and some other things like Valgrind. So GDB is the main debugging tool. I've seen people develop ones that are supposed to make it graphical and easy, and they all seem worthless to me, although I'm pretty much old school. The command line is best. So in GDB, you can start a program, you can step through it line by line, you can pause it with breakpoints, and you can show the value of variables at any point. You can continue after a pause, can examine crashes and examine the stack frame. So breakpoints are the main thing you use in debuggers of any kind. You stop execution so you can examine variables in memory. And some people put a GUI, a wrapper, around a command line debugger program, like a data display debugger. I use these on Windows, but like I say, on Linux, I find it to be more trouble than they're worth. So if you typically compile with -G, because then you can do source code debugging. Other than that, you're going to have to debug at the assembly level, which is pretty cool, but it's more difficult than debugging with source code, and that's usually what you'd rather do. Also, if you're going to debug, you should avoid compiler optimization. They tend to produce code that will confuse the debugger. So there's 01, 02, and 03, which we're going to talk a lot about later, optimizations, which make your code faster, but they also confuse the debugger, so they're not recommended if you're going to be debugging it. So here's some common GDB commands. Break sets a breakpoint, run starts running, continue continues from the current point, quit quits the session, and next executes the next line of C code. Now next, this is step over. This step goes into the function call. This is a big issue, and it'll be the bigger issue when we get to assembly code. If you want to execute one command, that's clear unless it's a call. And then the question is, do you want to execute the call, go into the subroutine, and stop there? Or do you want to execute the call, go into the subroutine, finish it, and return, and continue at the same level? And they call the second one of those step over, and the first one step into. And I think next is step into, and step is next. Next is step over, and step is step into. All right, lists the source code, prints out a variable, where prints the call stack, and frame moves into the context of a specific stack frame. So let's do a demo of this, and I'm probably going to have to make an adjustment here to get my virtual machine running on the right network. Right, it's NAT, so I gotta change it to bridged. All right, and then sudo dh client -v. Okay, 192.168.0.24. Let's see if that works. It does. Okay. All right. So I want to look at bad prog. So got a bunch of things ready in this directory, and one of them is bad prog. So if I cat badprog.c, all right. So here we have it. Comes from your textbook authors, of course, and so there's a function called find and return max, where you pass it a pointer to an array, length, and max. So if the array, let's see, if not array 1, right, now if array, I would mean array 1 equals 0, which means you passed it a null pointer, so it can't use it, or length less than or equal to 0, then it's no good, return with an error. Otherwise, set the maximum equal to the first element, and now for each remaining element, if the max is less than, right, if the array 1 is bigger than max, then set it equal to it, and then return 0. So this will find the maximum value and then return 0. The problem is the maximum value is here. It's an integer. It's not a pointer. So when you return, it's not going to return that value. So this is a defective program. So here's the array we're going through, 17, 21, 44, 260. So 60 is the right answer. And it's going to find and return max and then print the maximum value in the array. So if we run this, all right, we get 17, which is the wrong answer. All right, and we can see why, because we did not actually return that value anywhere from this subroutine. It counted the maximum, left it in the local variable max, and never actually passed it back to the main program. So that's an obvious flaw. All right. All right, so we compiled that thing, and now it gives the wrong answer as we saw. So let's debug it. So I'm going to shrink this to the side so I can see it while I'm working. And let's get the terminal here. All right. So we gdb minus q, bad program. All right. Now we break at main. And now run. And it will go and stop at breakpoint where main enters, breaking at this integer. Now if I list, it'll show me the 10 points around 10 lines of C where I am. So here's the int array. So it entered the main function, but it stopped before the first executable line in main function, which is where it defines this integer array. All right, now I could take a look at the other function, this find and return max. I could list that too and see the source code of that. And here it is, the first 10 lines of that, which largely a bunch of comments. It shows you some of this. All right, so if I do next, it's going to proceed to the next line from here. I'm at 36, so it's defining the integer array. Then it's going to get integer max, so next. All right, it goes to integer max. Now I can print max. And right now it's undefined, and as we should get used to in C, if something's undefined, it contains crazy data left over from previous things on the stack. We're going to have a lot of problems with this as we go forward. It leads to a lot of flaws. But anyway, it's just got random data in there now. Now if we continue to the next line, now it has executed this line here, which assigned max to array of 0. So now if I print max, it is 17. So there you go. All right, now it makes more sense. All right, now it's 17, and as we know, if I just continue, let's see, maybe I have some other plans here. All right, so we know it's never going to do more. All right, so now we know you're going to end up with 17. So we're going to delete the breakpoint, all breakpoints, and now we're going to put a breakpoint at find and return max. All right, I'll just copy it from there. I thought it would let me do text completion, but it doesn't seem to want to let me do that. All right, and now run. It's ready. I'm going to start from the beginning, yes. And now it's going to run and hit find and return max. So now I can list. I think it's still on my clipboard. Yeah. All right. So here I am. So now I'm in here, and I'm just going to delete the breakpoint, and then I'm going to break in line 26. So let's do another list. All right, so line 26 is down here where it's doing inside the loop where it's calculating the max. So I want to put a breakpoint there to see what's going on. So I'll put a breakpoint at line 26. And then display I, display max. And display array 1 sub I. And that it will do some tab completion on it. All right, and now what I can do is every time I continue and it hits the breakpoint, it'll always display the variables I asked it to. So here's the first iteration. I is 1, max is 17, array I is 21. Now if I continue, max becomes 21. The next element in the array is 44, and when I continue, max becomes 44. So the subroutine is working as it should, calculating max, max is correctly calculated as the value I want, but, and here's 60, and I think, yeah, max even gets set to 60. But if I continue, it goes to the calling program and returns max value in the array as 17. So that's the situation. The loop goes too far. Anyway, it doesn't really matter. Max is not passed back to main is the main problem here. Now, if the loop goes too far, let's see, I equals 5. It does actually, now that you mention it, which is interesting. If you look at the source code, the array is a 5-element array, so it goes from 0 to 4, and it did execute with I equals 5, so it read off the end of the array. We're just lucky that this undefined value at the end of the array happened to be 0. If it had been some big number, like that other undefined value, that would have come out. Can you explain everything again? I was janking. Yeah, all right, what's going on here is, let me go back to my slides. Here's the program we're working with. I'll make it bigger. All right. So this program, in the main function, I define an array with 5 values, and I'm trying to find the maximum value. So I set the maximum equal to array sub 0, and then I call this function find and return max. 5 feeding in the array, 5 elements, and the variable max. And then I print out the value max. So that's the idea. The problem is I passed to it max by value, which we've talked about. If you pass by value, what it will do is make a copy of max and make a local variable here named max. And so even though it correctly finds the maximum value in the array and assigns it to max, it doesn't return that to the calling program. So that's a problem. And what I just did was do that in the debugger. So you run it through the debugger, and you can run through and see that the max returns to 17. And when you run it here, let's just run from the start. I'll do it again. Somebody asked for this. All right, so I run from the start. The first time it's going to break every time it enters the loop inside max. So let me list max and find and return max. So if you look inside this function, and then list again will show me the remaining. Here's the function. So here's the loop that reads through the array and tries to find the maximum value. And I put a break at line 26 here. So each time it compares, just before it does the comparison, it prints out some values of variables so I can see what's going on. So if I continue, all right, so here it goes. First it started with max equal to 17, because remember, it's 17, 21, 44, 2, and 60. Those are the values of the array. So it started at 17, then 21 was bigger, so now max has been set to 21. And if you continue again, 44 is bigger, so max is set to 44. The next array element is 2, so it won't do anything from that, but the last array element is 60. So when you go here, it's going to correctly set max to 60. Now, one mistake in this program is it's going to run one more time. Going to I equals 5, which is off the end of the array. Just by luck, there's a 0 there, so it doesn't get the wrong answer. So we end up with max being set to 60, but the calling program still prints out the max is 17. We did not successfully pass the variable back to the calling routine. Sort of things you can find in a debugger. So there's the two problems we found. The loop goes too far, and sure, let me know. That's why you have humans to help. Yeah, exactly. Yeah, let me know if you need anything. We're not in any hurry. We got plenty of time. And okay, so that's the game. So you can see now, all right, and so we already saw max is not passed back to main. I don't think we need to do that again. And so those are things you can find there. Now, that would be easy enough to fix, but I'm just showing you how the debugger can be used to fix it. So now let's take a look at segfaulter. So let's quit this, and let's do ls. And I should have segfaulter here, and I do. Okay, cat. .c. All right. So here's segfaulter, and what it's going to do, it's going to, let's start at main. In main, it takes parameters on the command line, int argc and char star argv, and an array is set to a null pointer, and max is 6. So it's going to call init function of array 100. All right. Fair enough. Let's see what init function is. Init function here takes a pointer to an array and a length, and it fills that many elements with numbers, counting numbers, okay? The one thing that troubles me is I see up here up here it set the array to a null pointer, and it's going to then try to assign 100 values there with this pointing to null. At no point did we actually allocate any space to store that array, so I think this is going to lead to a problem. We're going to be using a null pointer. And then there's something called func down here, where it's going to call func array 100 max, and that looks like that's going to do like before. It's going to try to find the maximum value in the array. So it looks like a lot of bad things are going to happen when we run this. So let's just run it the way it is, seg falter. Okay, we got a segmentation fault, which is not too surprising. I would think you'd get one from that null pointer. So let's debug it. AULTR. For some reason, tab completion is again not doing it for me. All right, now we run and let it crash. And so here it's died at this point. Now I can do where to see the stack frame, and it will tell me, you're in main, and it crashed in init function. This is where you are. You're in init function, and if you were returned from that on the stack, you'd end up in main. So I now know it crashed in init function. All right. And I can list from where I am, and it will show me the line. So it crashed as soon as it entered init function from the looks of it. All right, so now let's take a look at some values here. We're going to have array I, and array itself, so we can print all those. I, print array, sub I, at the point of the crash. That's interesting, can't access memory, and print array. Array is a null pointer, and that's the problem. It's a null pointer dereference. You're trying to store data and address starting in null. And all right. And so now we can move into different frames. We saw 2 frames here. We could move back in the context of frame 1 and then do a list up here and see what's happening in main. And here we can see we set the array to be a null, and then we called the function on a null pointer. So that's pretty obviously the problem. If we print array up here, then we get null. So you're seeing this, you can track it down. In this case, it's pretty easy, but anyway, just showing you what good GDB can do you. And we're going to use GDB a lot more as we go ahead. All right, so there's keyboard shortcuts. Tab completes a command. Sometimes the name of a function will complete and sometimes it won't. Up and down repeat commands. Return repeats the previous command. Help gives you an online help message, which can be helpful, but it's often overwhelming because GDB has many, many functions, and I only use about 10 of them. There's a whole lot of complicated things it can do. All right, and so you break. We talked about break. Put a breakpoint in. Run will run from the start of the program. Continue will continue from the current point, which is typically a breakpoint when you're using continue. Step goes to the next line of source code, and next goes to the next line of source code unless it's a call, in which case it finishes the call and comes back, treating a function call as one line. So this is called step into, and this is called step over. All right. We'll execute until the specified line number. Quit will quit. List will show source code. Where will show the stack frames, and frame will move into the context of one of the stack frames. And you can do a lot of things with breakpoints. All I ever do is set them and delete them, but you can do a bunch of other things with them. And you can even set conditional breakpoints, which are an advanced feature where you do some kind of calculation and you only break if a certain calculation is true, which I've never had to use. But if you're doing complicated things, you might need to do that. And you can print a value of a variable. You can display a value of a variable each breakpoint. You can examine raw memory with X, which is mostly what I use, because I'm normally doing assembly language debugging, working on things like malware, which we'll get to. But if you're doing source code debugging, then you can print variables by their name. And what is will show the data type of an expression, which I've never used, but it might be handy if you're starting to write expressions for complicated things like conditional breakpoints. You can set a variable's value, and you can get info about the program. The main thing I do for info is get the registers in the processor, which we will get to when we move ahead into debugging assembly code. All right, so let's try a Kahoot, and I'll have to open them up here since I switched computers, but it shouldn't take too long to get in here. All right, we're here, and 3A is here. There we go. Now I think I got to make it narrower. There we are. That should work. All right, so what command will execute the next line of source code without stepping into functions? That's next that will do that. All right. Continue will just do many lines. It'll keep going until it hits a breakpoint or the end of the program or some kind of crash. All right, what command displays C source code? All right, that's list. List shows you the source code. All right. All right, what command automatically displays a variable at each breakpoint? That's display. All right. All right. Which problem will cause a seg fault? Yeah, null pointer dereference definitely will. Reading uninitialized memory often doesn't. As we've seen, you can read off the end of an array, although it could if you read so far out that you read memory that's not available to your program. And the same thing writing. You can write off the end of an array, but if you write to a really far distance out, you'll be outside the memory allocated for your program, and that will cause a seg fault. But a null pointer dereference will always cause a seg fault because no program is ever authorized to read or write from null. That's reserved for the kernel, the first page of memory. I'm not even sure if the kernel uses the first null byte, but anyway, nobody but the kernel ever could. The first page of memory is generally reserved for the kernel. All right. So the winners. All right. All right. I hope those are close to your real name. If they're fake names, you'll have to tell me your real name at some point if you want to get your points. But HT looks like real initials, and Helene looks like real name, and Colio might be close enough for my grader to figure it out, and it might not. Anyway, all right, so then you can try Valgrind. No, it shouldn't say you got 0 out of 4 if you got them all right, but what it might say is you didn't get very many points because it rates you on speed. But if it says you got 0 out of 4, that's not right. Anybody else have that problem? I had pretty good luck with Kahoot for a long time, so I'm. Let me know if other people are having trouble like that. Certainly, that's part of why it's extra credit. It's not under my control to fix it, but I haven't heard very many problems like that. Maybe we'll see. Maybe get to the bottom of that. Anyway, all right. So Valgrind can check memory errors with memcheck. And so you can tell you if you're trying to read value from uninitialized memory. Like here, I define pointer to be an integer, and then I allocate enough room for 10, and then I read pointer 3. So it is memory that's allocated for this use, but it has not been initialized at any point. So it's going to contain random data. So that's something I should probably be warned about. It's not going to cause a crash directly, but it is going to have a strange random value loaded in that variable. Also, if you set an unallocated memory location like here, I only allocated room for 10, but here I am writing to location 11, and then using location 11. So here I'm writing to unallocated memory and reading from unallocated memory. And one of the many cruel things about C is this will probably work fine, because you didn't really go very far off the end, just went one value off the end, so you can probably read and write to that, and it will appear to work. The problem is it's also changing some other variable that you didn't think about, which could drive you nuts. Anyway, so memcheck will also look at heap memory errors. For example, if you free the same pointer twice, that's very bad. That can lead to vulnerabilities. And memory leaks, of course, are very common. As you may know, Windows 95 had terrible memory leaks. It would crash after every hour or two. It wasn't until, I think, Service Pack or Windows 98 that Microsoft finally got it. This is a really common problem, that programs allocate memory for temporary use, but they forget to ever free it. So as you run the program, it just hogs up more and more memory and crashes. I use 2 programs that do this. Wireshark does this, and so does a log monitoring tool called sysmon. And they're both designed to do that. They're both accumulating data in memory, and you're not really supposed to leave them on very long for that reason. They will just fill up memory and crash. Anyway, so Big Fish. Let's run this one. I should have it ready to go. Let's get out of here. And cat, let's do ls. See, I have bigfish.c. Okay, cat bigfish.c. Okay. So here's Big Fish. Let's see, where's main? All right, there. It looks like it doesn't have any subroutines. It just has main. Now here we define, well, it's going to have a subroutine called print array, and here's the declaration of that. Okay, here's main, which has command line arguments. Int star big fish and star little fish allocate space for 2 integer arrays. Big Fish has room for 10 integers, and little fish has room for 10 integers. If big fish or little fish, not big fish or not little fish, which means if either one of them is null, then you quit, which means malloc returned a null pointer, which means you don't have any room left on the heap, so you can't allocate something. So this is a standard procedure you do when allocating the heap to be safe. You define, use malloc to get room saved, and then get room reserved on the heap, and then you check to make sure it didn't return a null pointer. So now I'm going to fill big fish and little fish with numbers. I'm only going from 0 to 9, so this looks okay. Now I'm going to print array. Okay, All right, here is a bad heap memory address. Now I'm going to go to 13 and set big fish to value. So this is going to run off the end of big fish. It's going to write a couple of integers off the end. And after the loop, big fish and little fish are going to print. And I think we'll find that one of these has gotten confused. Right, then we're going to free big fish and free little fish. Okay, and it'll crash here. I understand it. It's going to crash because we wrote off the end of a heap chunk. And as we're going to exploit this later and take over the box with a heap overflow, but a heap overflow, the way a heap works is you allocate memory for the integer, and there's a couple other housekeeping numbers stored at the start, like a pointer to the next heap segment and a pointer to the previous heap segment. And if you overwrite those, then it tries to use those to write values. And in this case, we've overridden it with small numbers like 66 plus I, and so it's probably going to end up trying to write to a memory location very low, like 66 plus something like 10. And that's going to give a crash because we're not allowed to write to such memory. And so print array just prints the data at that point. So it makes sense. So if I run big fish, there it goes. So here's big fish array, here's little fish array. After the loop, big fish is like this, little fish is like that. And notice this first number of little fish changed to 78. So I printed 75. Now 76 and 77 wrote on the pointers to the next chunk and the previous chunk, which arranged the organization of the heap. And then 79 was printed, 78 was printed at the data. So the two you don't see here are the two that caused the problem by overriding control values, and then you get a segmentation fault as it tries to write to one of those locations, 76 or 77. All right, and so we can, or it doesn't, like I mentioned, writing beyond bounds doesn't cause an immediate crash. Unless it hits some really important memory region, you're probably not using that memory region for anything else right now, and you can use it, write to it and then read from it. It's just that when you try to use some other variable that was supposed to be stored there, you've altered that value. All right, so we should be able to find it with valgrind. Valgrind minus v, big fish. Do I need the dot slash? Looks like I do need the dot slash. All right, good, let's try that. All right, here's valgrind printing a bunch of stuff, telling me about the memory. And there, I should see some errors here. So here it is, showing a lot of information about how memory is used. And then at the end, it's going to show me the summary. Okay, error summary, 3 errors. Invalid write of size 4 here. Address is 0 bytes after a block of size 40 is allocated. And here, 3 errors. So here it is pointing at big fish and 27. Main and main big fish C, a little hard to read, but you do see a write at this address, which I think means line 27. Let's try printing the code, or just look at it in the slides maybe. Yeah, I think it's a line of code, but I'm not quite sure how to read that. Anyway, it did show me some errors. 0 bytes after a block of size 40 was allocated. All right. All right. And let me see if I left myself any notes here to help explain how to read that valgrind thing, because it's a little hard to read. Nope. All right. Anyway, we saw here, saw the errors, but I'm afraid these numbers are not as helpful as I'd like them to be. But they do tell you something's wrong here. Invalid write off the end. Address is 0 bytes after, and then when it does the free, it's going to be a crash. But it doesn't give you a lot of details. So this is what tends to happen with these things to analyze memory and such. They give you data in a format that's hard to read. I've had problems with them. Anyway, all right. So advanced GDB features, we're not going to bother with them. Like I say, we've already covered more GDB features than I ever really use. You don't need all these fancy things. We need to allocate resources to teach looks maxing. Well, I'm not sure what that means, but anyway, probably a joke. Anyway, so, all right, let's take a look at simple ops. Simpleops.c. Make sure I got it. And I do. Okay, clear. Cat. Simpleops.c. All right, well, this is pretty easy. Okay, so we're just going to have x and y, and then we're just going to do things like add, subtract, multiply, and do a calculation. All right, looks easy enough. I think the point of, I'm trying to remember what the point of this one is. Oh, we're going to look at the assembly code. Okay, good, fair enough. So now we're going to compile it. I compiled it without the -G switch. So we're going to look at it in raw assembly code. Good, glad to see it. So we do GDB -Q, simple ops. All right, and now I put a break at main and run, which will get the program started. And now, I always like to do this because I hate the colors in this thing. They're too hard to see, so I set style enabled off. And now I can do disassemble main. All right, so now we can see the assembly code here. And that's good. All right. And so here's what the assembly code works. This, by the way, is all the stuff that creates the stack frame. When it enters here, it has ESP and EBP, which come from the calling routine. So it's going to push the old EBP on the stack, move ESP into EBP. So it's going to start a new stack frame at the first available byte below the previous stack frame. Then it's going to subtract 10, make room for the new ESP. This is what creates a new stack frame of size 10 with room for local variables. Then it calls this PC thunk thing, which is part of getting the start of a stack frame. Okay, now we're just going to do things. And so here you add EAX, you add some constant to EAX. Then you're going to move 1 and 2 into variables. Now this is what, let's compare this to the C source code. Let me get back to the C source code. It is quite useful to learn what C source code looks like in assembler. So I'm going to open up a new, let's see, all right, I'm going to show C source code here. Let's cat, what was this one? Simple ops, okay. Cat simple ops.c, there we are. So there's the source code. Let me get that to the side. And there we go. All right, there's the C source code, and here's the assembly code. So x equals 1, and we have two local variables, x and y, which are each going to be 4 bytes big, so it only needed to make a stack frame of 10, which is 16 bytes in hexadecimal. That's enough to have room for two 4-byte variables and some other things it might need. So then we're going to, I'm not sure why you're adding 2 EDC to EAX, I'm not going to worry about that. Here we are putting 1 in location -4 from EBP. That's this, x equals 1. -4 from EBP is an address on the current stack frame. Starting from the base pointer and going 4 bytes in, that's a local variable stored on the stack frame. And so we've put a 1 in there, then we're adding 2 to that same location. Then we're subtracting E from it. That's this -14. E is hexadecimal for 14. And then here we're going to move -4 EBP into EAX, do an integer multiply of 64 times EAX, and 64 is 6 times 16, which is 96 plus 4, which is 100. This is the multiplication by 100, the integer multiplication. And then here we're going to, the rest of this is going to do the add plus 6. So that's just what it looks like. All right. Yeah, I see a lot of comments there, which I don't really understand. There is, I'm sure, a lot of fancy Twitch features I don't know about. Anyway, all right. So here's some commands that are useful. You can set a breakpoint at a memory location. If you are not using source code debugging, you don't have line numbers, instead you just have memory locations. And you can do the next instruction, and here's step into the function. Just like next, all right, just like next does the next line of source code, and step does the next line of source code and goes into subroutines instead of going over them. It's the same thing where you add an I to do a single instruction, an assembly language instruction. All right, and you can print registers like EAX and so on. You can also use display to automatically display them at breakpoints. And info registers is the one I use all the time. So let me get back into my debugging here and show you that. There, if I get back into here and then put a break at main and then run. All right, now I can do info registers. This gives me a nice location, so I can see now ESP and EBP are here. Those are from the main routine. And if I do next I, and next I, and next I, that should do it. That should have given me a new stack frame, ESP and EBP. Now it's A48. The stack frame now goes from 4A8 to 4B8. That's the size 10 stack frame. And it looks like it was the same before. All right. Anyway, I'm not going to struggle with it much right now. But that's what I wanted to show you is info registers. We'll be using it a lot as we go ahead. And, all right. And there is a graphical debugger if you have Linux with graphics. But the Linux I tried it on with graphics, which was Kali, did not work. And like I always find, graphics on Linux is just not worth the bother. I mean, people who live on Linux and really get a good version like Mint or Ubuntu going and get into it can possibly use graphics on Linux. But if you mainly use the command line Linux, it's just too much bother to get graphics working on Linux. I don't recommend it. Anyway, let's do another Kahoot, and then we'll be into demos. So the Kahoot is 3B, which is here. All right. All right. I can see from the chat that people discussing what Twitch is mostly used for, which is gaming. Yeah, I know nothing about that. It's pretty good for college classes too. Good. I'll wait a bit longer. Well, my name is Sam Bound, if you're asking about me. I teach a lot of these classes. And they're available to anybody. Anybody can tune in. All right, good. I was talking about somebody else. Fair enough. All right. Anyway, let's give this a shot. All right. So what happens if you don't call free? Get a memory leak. You allocate memory and you forget to free it, so it's not available for further use, so you gradually use up a lot of memory. All right. All right, which GDB command displays assembly code? Disassemble shows assembly code. List shows C code. All right, and I don't think there is any assemble command. So disassemble and list are the two you'd mainly use. List for source code debugging and disassemble for raw assembly code debugging. All right, which one of these is a graphical debugger? DDD is a graphical debugger, a graphical wrap around GDB, which I couldn't get working, but I didn't try too hard. I'd have to install a real Ubuntu graphical system or something, I suppose. Anyway. Right. Yes. Okay.